Hey everyone, my name is Nick, and today we're going to talk a little bit about how we can use Veramo and DIDComm to bring identity to AI. Now, why might we want to do this? Well, we all know that AI can do some cool stuff, but it also presents some risks. Models that are trained on biased data can actually reinforce inequality, and a lack of interoperability can reduce equitable access to the models. So our goal is to help identify and correct biased models by adding auditability and to increase access by defining an open standard for user to AI communication. And we'll do this by building a system for verifiable AI interactions using our primitives, DIDs, verifiable credentials, and DIDComm. And the system will look a little bit like this. Pretty simple. Basically, a user agent will send a DIDComm message to an AI agent with the prompt, the question that they're asking the AI agent, and that AI agent will respond with another DIDComm message, this one containing a verifiable credential and including the response. So, what we'll do to accomplish this is we'll create a plugin for Veramo that handles these DIDComm messages. So you're going to want to start by going to the plugin template repository, hit use this template, and go through that process to create a new GitHub repository. You can call it whatever you want. It's just going to be a plugin that you use for Veramo. So go ahead, uh, use this repo, and then clone the repo that you've created to your local machine, which I've done already. And you can see here I am in Visual Studio Code. And we'll get started. So here we are in our plugin template repository. First thing you would want to do is run yarn to install all of your node modules, but I've already done that. It takes about 20 seconds. And then we're actually going to delete most of what's in here already. This template comes with quite a bit of stuff that we don't need here because it has a few different examples in it. So I'm going to go ahead and delete both those, as well as this types folder. We don't need that either. And then we'll rename our agent plugin folder to message handler because we're going to be making a DIDComm message handler here. And we'll rename this file machine learning text generation message handler. All right, so we're going to start by just creating a couple of helper functions. We don't need any of this stuff. I really don't need anything in here. We'll just delete all this because we'll start from scratch. But the plugin has all of the TypeScript configuration, your Jest configuration, everything you need to make a nice Veramo plugin in it. So we're going to create two little helper functions for creating our DIDComm messages, and each of these has a different message type. There's the prompt type and the response type, so I'll create a couple of constants for that. And then the first helper function will be for creating the text generation prompt message. I'm going to be copy and pasting here because it'll save a lot of time, so feel free to stop, pause the video, and enter this in yourself if you need some more time, since I'll be going a little bit fast. You'll see that we already have a couple of cannot find name errors here because we haven't added our imports yet. So we'll go ahead and add pretty much all of the imports that we need. See, most of these aren't being used yet, but we will be needing most of these. Don't worry about these errors. They are just Visual Studio, not recognizing this, but they are there, and those will go away. And then we'll also go ahead and we'll create a debug object so we can add our debug output when we need to. And again, this function is just going to take in some parameters and return an object that is the same shape as a DIDComm message. It has a type, a from and a to, as an ID, which will just be a UUID randomly generated, a thread ID, and then the prompt inside of the body object. And this return route will usually say that it'll usually be true. This return route object will usually be true because we want a response right away, which will put all in that variable. And then for the response, create another helper function that looks just like this, even simpler really than the other one. Takes in a bunch of parameters, as well as a verifiable credential here. And it'll just return another DIDComm message with the response message type. It takes the ID from the prompt and just tacks on response to it. Has the thread ID, and then the body of this message is just the verifiable credential that we're going to be creating. Now, let's go ahead and create one last helper function for actually creating that verifiable credential. It'll look like this. So this function is going to need a context, so it's going to need access to our agent context with the iCredential plugin. So this will allow us to actually issue or create a verifiable credential. And then it's going to need a few more variables, the actual response, what the original prompt was, the from and the to, and then it's going to return, of course, a verifiable credential. And this will be pretty simple. This is how any verifiable credential you create in Veramo looks pretty much like this. The real interesting stuff would be that we're going to be calling it a text generation response. That's the type of the credential we're working with. And then inside the credential subject, it'll have the original prompt, the response, and then these are basically metadata about how we got that response. So what was the machine learning model that we used? In this case, it's the StarChat beta model created by the Hugging Face team. What is the license of this model? This is an open source license with some minor restrictions in it that you can check out. And are there any research papers associated with this model? These are actually research papers associated with the StarChat alpha, but I put them in here just to show that you can link. You can use this to link research papers that might be interesting later. And we'll go ahead and just make this a JWT credential since it's a little bit easier to work with. So we have our 3 helper functions that we need. And now we'll go ahead and create the actual message handler. So really, we're going to make sure that this will be exported so we can later use it in our agent. It's a class, and we'll call it the ML machine learning text generation prompt message handler. And of course, this extends our abstract message handler class. One thing right away is that we know we're going to need an API key or token for interacting with the Hugging Face APIs. So we'll create a private class variable for that. And we'll create our constructor. So pretty simple constructor, just we'll take in our token as a parameter, and I'll show you how we do that a little bit later on. Stores it, and then we can use it later. And then this message handler just has one function inside, which all message handlers need, which is the handle function. So we'll create that, and these handle functions take in a message and a context. And they return a message as well. Again, don't worry about these errors. We're going to be fixing that later. Or actually, we can fix the context error right now. I forgot to add that up at the top here. So we'll create our context, and we know that if you want to use this message handler, you're going to need to use an agent that has at least these 4 plugins in it. Obviously, you need DIDComm. Since this is a DIDComm message handler, we're going to need our credential plugin in order to issue our credentials. And of course, you need your DID manager and your key manager to issue credentials as well. So now that we've defined our context, that error will go away, and this one will go away once we finish writing this function. So the first thing you want to do in any message handler is make sure that the message that it's handling is of the right type. So you say if message.type is the prompt message type, then we can actually do some stuff. Otherwise, you just ignore it and you let a different message handler handle it, or it just passes on through and doesn't get handled at all. And we'll put this in a try catch just so that we don't break anything if anything goes wrong. And we'll pull out a few fields from our message. We'll pull out the from, the to, the ID, the data field inside of it, the return, route, and the thread ID. Everything from the message. And then we can go ahead and create a couple, just a few checks here. So if there's no from, which would be pretty weird, we'll throw an error. We'll say weird. If this was a real message handler, you'd want to give it more helpful error message than that. But we'll just move kind of quickly and say whatever. This would be, if there's no to in the message, that would be extremely weird, because how did this message get delivered? So you definitely want to throw an error there. And then, of course, this one, probably a little bit more realistic, you might get a message of the right type that doesn't actually contain a prompt. So you would want to throw an error there. That's pretty much all we have to check. Maybe you would want to check the thread ID also. But otherwise, we can just move forward. So the first thing we'll want to do is actually, we'll go and get the answer, but we'll save that actually. So we're just going to do a little placeholder for now. So let's say we went off and we got the answer, and the answer is yes. This is pretending that we did. Let's pretend we did our API call to the Hugging Face instant that we want to talk to, and we'll handle everything else, and then we'll go back and fix that. So now we have our answer. We want to create a credential. So we'll just use our helper function that we made earlier and pass in, of course, the context, the answer, the prompt that we used to get the answer, and the from and to fields which it needs. So now we have our credential, and we'll want to wrap that up in the DIDComm message type that we defined using our other helper functions. So we'll create another object called our response. It'll be create ML text generation response. That should probably be called create response message. So rename message, just so it matches the other one that we already had created. And takes the credential as well, of course. And then we'll take this DIDComm message and actually pack it as an actual DIDComm message. So we'll say the packed response is we'll use authcrypt for our packing type, so it's an encrypted message and we know who it's from.
And now we'll try to go ahead and actually send this message back to the original sender. So let's just, whoops, don't know what happened there. Just create an empty sent object that we'll use later, and we'll check the return route that I mentioned earlier. So if the return route is all, like we said it probably will be up here, since we expect the response right away, we will try to send this message back in the same as the response to the to the HTTP query that started this. And all you have to do there is create a little object, call it return response, and give it a couple of fields. And then add this object to our existing messages metadata, and with the type return route response. And the value would be the stringified return response there. So this is all you really have to do to make sure that this message will get sent back. Adding it to the metadata here means that later on in the message handler flow, which is already defined by the existing message handler plugin, it'll check the metadata, and if there's anything there, it'll attempt to send it using that same transport. Otherwise, if this return route wasn't set to all for whatever reason, we're going to try to just send a message normally. So DIDComm agent.send DIDComm message. So this will also, this will try to send the DIDComm message. The reason you wouldn't want to do this every time, no matter what, is that the original sender might not have an open endpoint if it's if it's a mobile app or a web browser that originally sent the message. It might not have endpoint to be able to listen for DIDComm messages like that. It can only receive messages if they're returned in the HTTP response. But if it's from a cloud agent and it feels like it's using some other transport for some reason, maybe you can just send a DIDComm message normally with all of that. And then to be safe, we'll add another bit of metadata to our message, and we'll call it ML generation. This probably shouldn't have spaces in it. Doesn't really matter, but just to match the existing patterns we have, we'll get rid of those spaces, and the value will be that will be sent. So that, again, this value will only be will have anything in it if it used this part of the conditional. Outside of this, we just have the catch part of our try catch, which will just debug the exception for now. I don't need to do anything special. And then this part returns the message. And then outside of this, so if it was handled, it'll just return this message. Otherwise, if it wasn't handled, we'll pass it on to the next or the super handler, which will then pass it on to the next message handler to see if it can handle it. So that's pretty much everything we need, other than actually going and getting the answer. In order to get the answer, we'll create another new file just to have a little helper. We'll call it hugging face helper. And this is going to be a little bit hacky, just the way that this API is designed. The text generation API is a little bit weird. First function, simple query function. This is the API endpoint that we're going to be hitting. It's the Hugging Face star chat beta endpoint, and this is what a query to that endpoint needs to look like. But we actually have to do something a little bit weird, because putting in a question doesn't just get you an answer, it gets you only part of an answer. So it can return a like half of a sentence or half of a paragraph, and you actually need to do some kind of weird stuff to get it to return the entire answer that you want. You have to kind of go back and forth to this endpoint a couple of times. So we'll create this get answer function. Now don't worry too much about this. Again, it's a little bit hacky. It's not really the point of this exercise, but basically it uses some special syntax to tell the star chat endpoint that we've ended our input. That's this, and now we want the assistant to start talking, and then we're going to basically go and query the API endpoint until, and we maybe do it up to 100 times. That's probably overkill. We maybe say 10 times, and we're going to keep querying it until the response that we get has another one of these end tokens in it. That means that the API endpoint is telling us that it's done with its answer and it's ready for us to ask a follow-up question. Again, don't worry about this too much. Not really the point of the exercise, and there's probably a better way to do it, but this does work for a proof of concept. So now we have that, and we'll just go ahead and make sure that we call it over here. So it'll be and make sure to pass in our API token so that it will actually work. Then you're going to want to make sure you fix your index. Again, we've deleted almost all of this stuff, so that makes sense. And we'll just make sure we're exporting our message handler correctly. And that's pretty much it for this Veramo plugin that we've created. That's all we need. If this were a real plugin, you would want to go in and update the unit tests and make sure that you're actually testing that the thing works the way you think it would. But we'll skip that for now. If you want to see a version of this that does have some minor unit tests in it, you can find it linked in the description. But we'll skip that for now. Again, you can find this whole plugin linked in the description on this video. The next step would be to simply build this thing. So you would run yarn build, and then once it's built, we'll see if are there going to be any errors? Let's see. Some of these are because we never added the types for debug. And for UUID, it's saying it's not a module, which is a bit weird. Did I forget to save it? Yes, I did. So there we go. It's built correctly. And then you would go ahead and, well, you'd want to modify the package. So it's not called Veramo plugin template. You'd want to call it ML text generation message handler, probably. And probably have to clean this up a little bit, and then you would run, npm publish and go through the normal npm publish flow, which will make it a lot easier to add this plugin to a cloud Veramo agent. I've already gone through and published this, so we'll skip over to how we actually add it to a cloud agent.
So in order to create a cloud agent that has our plugin installed, we're going to use another template. This is the Veramo agent deploy template. You'd click use this template and create a new repository for that, and then clone that to your local machine, which I've already done. So here is my Veramo agent deploy. I've created a new branch indicating that this is the Hugging Face deployment, and then you'll have two configs. Agent-local is just for testing locally. If you run, I believe, well, we can double check actually. Yeah, if you run yarn dev, that'll just run it locally, so you can make sure that your changes are doing what you expect them to do. And then this agent without the -local is the one that will actually be deployed on Heroku or wherever else you're going to be deploying this. So the only thing that we have to do here is modify the message handler plugin a little bit and add this bit right here. So again, I've already deployed or published to npm the package, and then we say we're requiring this class from this package, and we're passing in the correct token. You can see actually that we define this token up at the top here, and then we'll be able to go in and actually set our environment variables so that it all gets deployed correctly. So go ahead and we would push this branch, and then we'll go over, again, we're going to be working in Heroku, and I already have a version of this deployed to Heroku. And then to deploy this branch, I would just go and, I have my GitHub correctly connected, and I would select my branch, deploy the branch. Eventually, I'd have to go in and update the correct, make sure you add the environment variables. I'm not going to show you my config variables here, but you would click this and then make sure you add the Hugging Face token in correctly. And then once this is deployed, that's pretty much all you need to have a cloud-based Veramo agent that can answer these text generation prompts that are sent to it. When it receives a DIDComm message with the right type, it'll send back a DIDComm message with a verifiable credential containing its answer. So how do we want to actually send those messages? Well, we'll use a version of the Agent Explorer. So again, in order to interact with the cloud agent, we're going to use our Agent Explorer, which is a React application. So what you would want to do is go ahead and fork this repository, make your own, clone that to your local machine, again, of course, which I've already done, and make some modifications so that it can support sending these sort of text generation messages instead of just a normal text message. So we'll skip most of this since it's not that interesting. It's really just some React modifications. You can find this branch of the Agent Explorer if you check the description of this video, but I'll just show you a couple of pieces of it. When you go to send a message, it'll say, we'll let you know what type of message based on that, and if it is a what we call a star chat message, it'll go and create the correct text generation
message, and then we have this another message handler, which just handles saving incoming messages. We'll want to make sure that we check the type of the message and if it is the right type of this text generation response. If we've received a message in our React managed agent, we'll want to make sure we save that message. And then other than that, we've just sort of created another UI similar to chats called star chats, pretty much just copy pasted it to put it in a different place for this proof of concept demo, make it a little easier to keep track of things. And then if we run this, we can go over here to our Agent Explorer. Now the Agent Explorer allows you to connect to a cloud agent if you want, but it also just runs a local agent in the browser. So what we would start off by doing is we want to create a new DID. You'll see it already has the DID for me since I have a Tallyho wallet, or I think it's called Tahoe now, extension installed. It's called MetaMask, but it's actually Tahoe. Doesn't matter because we're going to be creating a new identifier anyways. Let's call it test1, and we're going to use the did peer provider since this the did peer will give us the ED25519 or X25519 keys that we need in order to send and receive DIDComm messages. So we'll create this new DID managed by our local browser agent. Close this. And then we'll go over to our star chats window and we'll try to send a new message to our cloud agent, which we deployed earlier. The cloud agent has a DID of did web dev Veramo agent.herokuapp.com. So we'll create a new thread to this agent and we'll ask a simple question: what is Veramo? Now this sends the DIDComm message up to the cloud, and it performs its API call and returns a verifiable credential with all the metadata associated with the agent and our answer. Veramo is a set of libraries and tools for building decentralized applications on the web. It sure is. So we hope you enjoyed watching this little demonstration of how you can build a DIDComm protocol for interacting with AI agents and provide a little bit of auditability to the experience of interacting with AI. We welcome you to check out our website and GitHub repository, as well as join our Discord if you have any questions about DIDComm or anything else Veramo related. And links for all the repositories mentioned in this video, again, will be in the description below. Thank you.